Hello everybody, this video is on impulse. Before we delve into the concept of impulse, we need to first understand the relationship between the concept of force and momentum. Now, force is equal to the rate of change in momentum. This is because, by Newton's second law, we know that the net force acting on a mass is equal to the mass multiplied by the acceleration that is resulted from the net force. We can rewrite acceleration as the change in velocity divided by the change in time. And this is then equal to mv minus mu divided by the change in time. As we discussed in the previous video, the momentum of an object is given by the product of its mass and velocity. So in the numerator of this expression, we have mv minus mu. This is also known as the change in momentum of the mass, as we are finding the difference between its final momentum, mv, and its initial momentum, mu, divided by the change in time. This is why the net force acting on an object is also given by the change in momentum over the change in time. This is the rate of change of momentum. When we get a graph that looks at the relationship of an object's momentum over the change in time, the gradient of this graph is the change in momentum divided by the change in time, as the momentum is the y variable and the time is the x variable. So by finding this gradient, we can then find the net force that's acting on the object to cause the momentum to increase. For example, because the momentum versus time graph gives us a straight line, that tells me the gradient is constant and the net force acting on this mass to cause the momentum to increase is also constant. As we just discussed, the force acting on an object is given by the change in momentum over the change in time, also known as the rate of change of its momentum. If we rearrange this equation, we can also say that the product of the force multiplied by the change in time is equal to the change in momentum. Now in physics, the product of force and the time duration over which the force is acting on is also known as the impulse. So the impulse, which is F times by t, is also defined as a change in the object's momentum. The units for impulse can be either written as Newton's second, because it is equal to the product of force and time. The unit for force is Newton, and the unit for time is second. Alternatively, you can also use the unit for the change in momentum, which is simply kilograms meters per second. Since impulse is given by either force times by time or the change in momentum, both force and momentum are vector quantities. Impulse is also a vector quantity, which means we need to supply the direction in addition to its magnitude. A 100 kilogram mass is acted upon by a 500 Newton net force to the right as shown for a duration of 2.5 seconds. What is the impulse of the force and the final velocity of the mass? The impulse of the force can be easily calculated by multiplying the net force by the duration of time over which the force is applied. Both of these variables are given by the question. So the net force is 500 newtons multiplied by a duration of 2.5 seconds. This gives me an impulse of 1250 newtons second. You can also give the unit of impulse in kilograms meters per second, the same as momentum. To find the final velocity of the mass, we need to consider the alternative equation for impulse, that is, impulse equals to the change in momentum of the object. The change in momentum is also equal to its final momentum, that's called the mv, where v is the final velocity that we are trying to determine, minus mu, where u is the initial velocity. Since the object was initially at rest, its initial velocity is 0. So the impulse of 1250 that we previously calculated is simply equal to the object's final momentum. This is equal to its mass of 100 kilograms multiplied by its final velocity. So its final velocity is 12.5 meters per second to the right. The direction of the velocity is to the right because in this example, I've already previously defined the right to be positive and the left to be negative. An 800 kilogram car moving at 30 meters per second collides with a wall. The collision causes the car to come to an abrupt stop in just 0.25 seconds. What magnitude of force does the wall exert on the car during this collision? We can start the question by considering the change in momentum of the car. This is equal to mv minus mu. The mass of the car remains to be 800 kilograms during the collision, so 800 times by 0, which is the final velocity as the car comes to an abrupt stop, minus 800 times by 30 meters per second. This gives a change in impulse of minus 24,000 kilograms meters per second. So the car's momentum decreases by 24,000. Now, I've only considered the change in momentum of the car because the change in momentum also equals to the product of the force that acts on the car multiplied by the duration of time. Minus 24,000 therefore equals to the force that the wall exerts on the car. So this will be heading towards the left, multiplied by 0.25 seconds. So that the force equals minus 96,000 newtons. A 0.5 kilogram ball moving at 3 meters per second on the frictional surface collides with the vertical wall as shown. The wall exerts an average force of 120 newtons on the ball for a duration of 20 milliseconds. So when the ball comes in contact with the wall will exert a force of 120 newtons towards the left. If we define the direction to the right as positive, so that is plus 3 meters per second, this force acting towards the left needs to be minus 120 newtons. Part A, what is the final speed of the ball? Since the question has given us the force and the duration over which it is acting on the ball, we can easily find the impulse by multiplying minus 120 newtons times by 20 milliseconds, which is 20 times by 10 to minus 3 seconds. This gives an impulse of minus 2.4 newtons second, or you can write the unit as kilograms meters per second. Finding the impulse here is useful because impulse also is given as the change in momentum of the ball, which is its final momentum after the collision of the wall minus its initial momentum. Minus 2.4, which is impulse, is equal to the ball's mass of 0.5 kilograms times by its final velocity minus its mass times by its initial velocity of 3 meters per second to the right. This gives a final velocity of minus 1.8 meters per second. So this will be 1.8 meters per second to the left. Part B, how much mechanical energy was lost during the collision? So recall that mechanical energy of an object is given as the sum of its kinetic energy and potential energy. Since the ball was moving horizontally, there wouldn't be any changes in its gravitational potential energy. So the only type of mechanical energy that we have to consider in this instance will be its kinetic energy. The change in its kinetic energy is half mv squared minus half mu squared. We already know the final and initial velocity of the ball, as well as its mass. So it'll be half times by 0.5 times by 1.8 squared minus half times by 0.5 again times by 3 meters per second squared. This gives a change in kinetic energy of minus 1.44 joules. This means during the collision, 1.44 joules of kinetic energy has been transformed into other forms. This could include energy such as heat or sound. As you can imagine, the collision between the ball and the wall would result in a sound or acoustic energy and some amount of heat produced. This concludes the video on impulse.